So we look up the anion. So the anion is this. What is NO3's name? If you don't know, since Sheena's up here going, nitrate. Okay, if you're not sure, remember, if you're on this side with the solubility rule, what could you do? Flip it over to the back side, and what does it say beside NO3 over here? It says nitrate, right? So if we look up nitrate, what does it say about all nitrates? They're soluble. So what symbol did we talk about we'd write beside soluble before the break? AQ. All right, so AQ. Now, does it list any exceptions at that bubble? Does it say all nitrates are soluble except blah, blah, blah? No. So that means all nitrates are soluble, so you write AQ. Okay? So, if we do this one, what is our anion? AGI. What's the anion? Did you stick over there today? All right, so iodine. All right, iodine is the anion, so it's an iodide, right? So, all iodides. So, iodides are here. So, all chlorides, bromides, and iodides are soluble. So, again, we're going to put AQ. But this time, it says except. So, what do we look at for the exception? The first element. So, we had AGI, right? So, because it says iodide, soluble, we put AQ because it's under soluble, right? Now we check the exception. The exception says silver, lead, and mercury. This is where we look for the exception. Is this silver, lead, or mercury? So it's the exception. So if it's the exception, we change the AQ and we make it what? We make it a solid. The AGI is a solid. Does that make sense? Okay? Does that help refresh your memory on how to read the rules? Think you can do those two now? All right, so that was an F. All right, you do those two. And then we'll see if you're on the same page I am. What? All right, got them? I'm going to remember here tomorrow again. All right, so K2CO3, what do you think? Everybody with AQ? Everybody not get AQ? Okay, got a couple of sour faces out there. So if we look at K2CO3, what's it say about CO3? What do we know? What is it? The carbonate. All right. So all carbonates are what? What do we put for insoluble? Let me ask you that first of all. That's a solid. It's an F. Okay. But it has an except group, right? What does it say except? Group 1. All right. What can you tell me about that? It's in group 1. So if we were going to put S here, because that's in group 1, what do we do to the F? We make it AQ because K is the exception. All right, BaSO4. All right, what do we know about it? is what? All right. All sulfates are what? All right, so we would put AQ here. Okay. Is that listed as an exception? Yes, it's got except variance. So except means I do what? The AQ. Change it to a what? And I change it to F because it's the exception. So I got to flip it. Questions about how to use the rule? Okay. So what does dissociation mean? Anybody remember what dissociation is? To dissolve it and do what with the compound? Break it apart into ions. So what do ions make up CaI2? Ca and I. Ca plus I. All right. Now, how do I show their ions? There's two things I have to do. All right, I'll need to balance it at the end. So what do I have to do before that? Oxidation number. So what oxidation number does Ca have? Okay, +2, and iodine. Sam is coming rapidly here. And y'all can't give me an oxidation number? Are y'all just that sleepy? I know it's been a while. Y'all are off your schedule, so kind of bad, but come on here. Group 2 is +2. Group 17 is -1. What else do I need to do to show that it's a ion? There you go. This is the aqueous. All right. And somebody said just a second ago I got to balance it. So what do I do to balance it? You got 1 Ca, 1 Ca, 2 I's. I'm going to put 2 there to balance the I's. Questions about how I did that? No diatomic. No diatomics in their ions. Because remember, they're diatomic because they're not happy at not having a full outer shell. They don't exist without having 8. When you have that oxidation number -1, they have 8 electrons in their outer shell. So they're perfectly content because they have 8 electrons. So they don't need to bond with somebody else to get their 8. Question. All right. Now, before we talk about precipitation and double displacement reactions, let's talk about the calendar for a second. We're supposed to test tomorrow. We're on a 2-hour delay. We have 63 questions there. Okay? Most of you can't do it in an hour. Okay? Dang. Most first period can't do it in an hour. Okay? So, we voted to support in first period. I'm sincerely sorry that y'all didn't get to be part of the vote. But you didn't get a choice. We have elected, or I should say they have elected, to, I gave them 2 options. A, to lose the test altogether. B, to shorten the test, which we would have to do on Friday, because I cannot cut and paste out all of the test parts by tomorrow. It would have to be Friday. And they elected to lose the test. So if you were really counting on keeping the test, I am sincerely sorry. Now, before anybody gets all bent out of shape because you're like, oh my God, I had to have that test for my grade. First of all, odds are good. Your grade is not going to move all that much mathematically anyway. It might have moved 1 or 2 of you a couple points. Now, Alexis might be about the only person in here who really needed that test paper. Okay, Alexis. Okay, because he's got a gas wall test that is pretty abysmal. Okay, the rest of y'all probably not going to make a whole lot of difference in your lives. So we have elected to skip the test, given we've lost an hour and a half class period between 3 days. We just eliminated it. Okay. And I had hoped not to lose an hour and a half or 2 hours tomorrow, so that we could put in a lab with today's topic. But given he cut the delay tomorrow and Friday, we lost the lab too because it's cold and a lot of people walk. People have to stand at bus stops, and it's difficult to get the bus in. Not all of us. Remember, Andy, not all of us went to school in Alaska. And they also have to get the buses running in the morning. Yeah, there are multiple reasons why we're delayed, but in general, they're not as sensitive as we are. Okay? They're not as sensitive. Regardless, because of the fact that we are delayed, I had to cut the lab and the test. So, nixing those things, that's where we are on the test. And I'd also have to nix tomorrow's review because tomorrow's test would then run over into what? The review. Now, I told you I would do 3 reviews after school for the exam. Tomorrow, Tuesday, tomorrow, next Tuesday, and next Thursday. Each of those reviews is worth a half a point on your what grade? This quarter. Thank you, Andy. No, you keep trying to make me say that, but it's not. It's on this quarter. Next Tuesday and next Thursday. The snow is staying east generally of 95. There is some that might come a little further. We might see some flurries. Okay. We're not really supposed to get any unless the models have changed since this morning. And perhaps they have. Okay, perhaps they have. I've not checked the Weather Channel since this morning, but this morning we were not supposed to see much of that. And the air was pretty dry. The dew point was really, really dry this morning. So unless the dew point has gotten a whole lot wetter, we don't stand much chance. I don't know about y'all. This thing does not say much about it. The humidity is 28%. The dew point is 1. That is not the participate. Wow. You need more moisture in the air to get stuff. And we just simply don't have it. Like, so, you might get some. Or like you might. Yeah, the humidity is 27%, and the dew point is just so low. We don't have enough moisture in the air. And I saw next week there'll be rain. But next week the temperature is supposed to moderate and be more what we're used to. So the odds that we will see snow next week are less. But, you know, if we get it overnight, you might see something. There you go. You know, but if we were on the coast, in coastal North Carolina, we would get something because they've got the cold air and they have the moisture coming up. Because we're just not in a position to get it. I put it in my calendar, but you put it where you want. Yeah, you just got to set it up so you get it to work. There's always a chance you can have a delay on the exam. Yeah, you have done exams with a delay. But yeah, remember, guys, the part that y'all always forget about exams is exams are normal school days. They're 8:20 to 3:30 days. So when we have a normal school day, can we run an exam schedule on a delay? Yes, the exam is still a 4-hour block of time. We just start the exam at what time? 10:20, and we run it 4 hours. Okay? Oh yeah, we've done it before. Many times if we have bad weather or it's cold or whatever, we just run it 4 hours from 10:20. Y'all just assume the exams are early dismissal day. Okay? Now, again, I've not been told otherwise, so I'm assuming that attendance will not count against you if you all bail after exams are done at the end of the first period. If you go, that they won't count against you. I've not been told otherwise. Okay? So what? They won't. Okay, I've not been told otherwise, so I'm assuming it's the same policy as always. Yeah, well, we have to mark you absent because if there's a fire issue, we have to know who's in the building. We also have to know if the cafeteria. What? 4:30.
Oh, yeah, so what are like, how does this, you know, the testing schedule? Like,
Yeah,
okay.
the testing. If you have a non-NC final, all right? In here, this is an NC final exam. You have a vocab class. You have it, none of y'all are sophomores, right? Okay. Any of y'all have English 2?
Oh.
Okay. Those would be EOC classes. Okay. So if you have an EOC class, okay, that would be a state test class 2. Okay. Any of those classes, those you have to show up for. Okay. Now, if you have a teacher-made test class like Spanish, art, probably JRPC, gym, psychology, anything like that. Those exams are next Wednesday and Thursday. Your teacher should hopefully already have told you what day she or he are testing you. Like this Bowers first period applied biology, she told them they're testing Thursday. But if you don't know, ask your teacher what day you're testing. It's a normal bell schedule those days. We're not changing the bell schedule. You're getting your exam in an hour and a half block of time. Yes, ma'am. Have somebody else wasn't there.
Everybody.
Well, I went. 40 minutes before. Oh, what? 30 minutes before. Now, so those 2 days are the teacher made test. Next Friday is the first period exam. Okay? So if you have an NC final, which is like this class, a vocab test, or an EOC, you have an exam next Friday. Now if you have a AP test, they may not be giving you any exam, okay, or something like that. But for an AB day class, it's only half the semester. Some of them might be given a midterm, or some of them may be choosing not to give you anything, and you may not have an exam. Okay, you'll have to ask those teachers what their options are. The first period exam is Friday. Okay? Then we go home for the 3-day weekend. It's Martin Luther King on Monday. And then Tuesday you come back to school and we have second period exam. Okay? And then Wednesday is third period. Friday or fourth period on Thursday. And then on Friday, there's makeup day. Now we're not supposed to tell anybody not to come to school. And I'm not saying don't come to school. But however, keep this in mind. All of the teachers, particularly like for those of us in science, there are 6 of us. 2 of us will be doing earth science testing. 2 of us will be doing biology testing. 2 of us will be doing physical science testing. Do we have time to babysit people during the day? No. No, we don't. We're all slated to do makeup tests. So if you just show up, the point in this conversation is, will you be here with me all day? No. You will be housed somewhere else in the building for them to babysit you while I do what? I do makeup testing. It's not like they're going to ring a bell schedule for you to go first, second, third, fourth. They round you up and put you with people while the rest of us do makeup testing. Okay? So, that's the schedule. And then the following week, I think there's 2 teacher work days for us to switch all the supplies out for starting the new semester. And then when you come back and you've got, what? Yeah. That's correct. Yes, they don't want the teacher-made exams messing up the schedule and having you guys here during regular exam day. Yeah, so like chorus, if you don't have a chorus exam on chorus day, that day you don't come. So then you don't come that day. Which is why I'm offering the reviews for you guys at the same time I'm doing first period. So if you don't have an exam that day, you don't have to come that day. See? You just stay home. You don't have to figure out how to get here in the middle of the day or whatever. Everybody good? Okay. Let's move on. I explain the calendar. I want them to have this class. The exams start next Friday. Not this Friday, but next Friday. So you're really 70 school days to start these exams. Good. All right. Let's talk double displacement reaction or precipitation reaction. What? Yeah. 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 First exam is 12. So you could review it on the 8th after you will wait. I don't know what it is, but if we couldn't, they'll carry over for next semester. Starting. Alright. So, precipitation reaction. First of all, what did we say a precipitate was? Way back at the beginning of the semester, and what did we refresh our memories on that it was right before we went home for break? Alright. So to refresh and I want to add something to it. Alright. Two aqueous solutions make a solid. Alright. So the only thing I changed is instead of saying two liquids make a solid, I changed it to two aqueous solutions. Okay? Because instead of saying two liquids, we're more sophisticated now. We know that aqueous solutions are essentially solids dissolved in water, right? So, if we have two solids dissolved in water, when we mix those things will form a new solid. So, before the break, we started writing an equation, and we got to a certain point and we had to stop. I'm going to write that same equation. We'll start at the beginning and work our way through it. Alright, so if we have this reaction, if you saw this, I just said we were doing the same reaction from before break. So, if we had this reaction, what would we know to do? Okay, double splice. So, what steps would we do in a double splice reaction? What would we do to displace? How do we know to split? All right, so how do we get the positive and negative? So how do we determine the oxidation number? Oh, we need work for this today. All right, so how do we get the oxidation numbers for BA? So what group is it in on the periodic table? Is it what? Group 2. Y'all might need a periodic table out of your memories as rusty as Brandon's over here because he's trying to think your memories. All right, so plus 2. What's nitrate? All right, potassium and sulfate. All right, so who's switching? Say who? We switching? Okay, so give me one. All right, so who's going to be with BA? Okay, and who's going to be with K? Okay. Now, notice the only numbers that came across were inside the what? All right, so what do I need to do now that I have switched them? All right, so BA is with +2 and SO4 is with -2. So what happens to those? Good. And K has a +1 and the other 3 has a -1, so they cancel out too. All right, so when we wrote this step down before break, I said step 1 was to double display, and what's the new piece? I said, what is the new piece? Okay, determine the state of each product. And if you remember, I told you you're in a first year class. So in a first year class, each product, one will be A and one will be A. You remember what I said? Okay. All right, because in a first year class, one will be a solid and one will be an aqueous. Okay? So if you were taking an AP class, you might get 2 solids, you might get 2 aqueuses, but because you're in a first year class, you will be guaranteed to get 1 solid and 1 aqueous. Nobody's going to try to trip you up and give you 2 solids or 2 aqueous. Okay? So, using your trusty chart, tell me what mistakes are. Which one? Which one is the solid? The first one or the second one? Which one? Give me the name of the compound and tell me. It's not an eeny, meeny, miny, mo. Use your solubility chart and read them. How do you know? Are you sure? Okay. All sulfates are soluble. Okay? All sulfates are soluble, so it should be AQ except DA. So if it's except, what do I do to this AQ? I change it to a solid. Okay? That's the part I wanted. Not I had it written down from before. So all nitrates are soluble. They're all soluble. So I just write down AQ. Okay? It doesn't matter because there are no exceptions for nitrates. They're all soluble. Any questions about that? Okay. Now, did we get to the work step? So I did the work step. Did I actually work out? Okay. All right. So step 2, for those people who are absent, is commonly called the work step. The work step is never an answer to anything. All right. This is why we did number 2 in the opening. You have to dissociate all aqueous compounds. Okay. Going to dissociate all the aqueous compounds. All right, does everybody have it? All right, you rewrite this real quick. You don't have to rewrite it on your paper. You've already got it. I'm going to have it really, really tiny on the board if I don't rewrite it. I have K2SO4, so I have it. BaSO4 first. All right, so that's what we had, right? All right, the work step. We're dissociating everything that's aqueous. So who are we not dissociating? All right, so I'm going to bring it straight down. Everything else we have to break apart like we did the CaI2 in the opening. So, taking our first ion, Ba, the oxidation number is +2. Its state is AQ. The other ion that makes it up is NO3, -1, aqueous. Now, the next aqueous compound is the K2SO4. I'm going to do the same thing to it. I'm going to break it apart. Plus SO4. Now, all I'm doing is making sure they stay aqueous, and I'm including their oxidation number. So all I did was split the compound in half, and I put in aqueous. That's all I did. Okay? Now, I have one compound to go. I haven't done the KNO3. Okay? NO3 has to also be split. So, now they're all split. All right, everybody caught up? Now, the work step is used to get the last things we need. All right, there. All right, so the last two things we need are the spectators and the net. So the spectators are the easiest one to do next, except for number 3. All right. What does spectator mean? What? All right, somebody's what? Spectator ions are just that in chemistry also. They watch, they don't participate, they didn't make anything, they didn't do anything. So, what are the ions that didn't do anything? They didn't participate, they didn't do anything in the reaction except go along for the ride. No, because BaSO4 is a solid here, and it started out what states here. All right, so it started out as aqueous, and it turned into a solid. It made something. That's not a spectator. K started out as aqueous, meaning it was dissolved in water, and it's still dissolved in water. It didn't make anything. It didn't do anything. It started out dissolved in water, still dissolved in water. It didn't produce anything. Okay? The easiest way to find these are the ions that, these are the ones that we can cancel out. So which ones are the same on both sides? Okay? And NO3. You know how in math class, you have an x squared on the left and an x squared on the right. What do you do with an x squared on the left and an x squared on the right? Same thing here. So the spectator ions are K plus with an aqueous at the bottom, and NO3 minus 1 with an aqueous at the bottom. Now, notice I just put commas between those. There's no reaction there. We can form anything. Those are just the things that cancel out. Now, step 5 sorry, so 4 is the net ionic reaction. Okay. Step 5 is the net ionic reaction. That is everything left. Whatever is left is the net ionic reaction. So what's left? Okay, this is left. The SO4 is left, and this is left. So that is my net ionic. So Da plus 2, the aqueous, plus the SO4 minus 2, the aqueous, the Da, SO4, and the solid. All of that was left. Yes, because this time, we write this in the equation because we actually made something. We made the solid, we made the precipitate. Now, you want to make sure that you balance if necessary. Now, is this one necessary to be balanced? Yes. Yes. Only water, do not go into the balanced class. If you do, you will not get water again before you get out of it. Like after you exam out of it. Question. About easy? Okay. I think it is, but you tell me my views are skewed all the time. All right, got it? Can we try one? We're going to do it in steps. All right, I want you to do the double displacement and find the state. Double displace and find the state. All right, you got the double displacement and the state. I did. Did you? What's that? I'd ask your glad to be back in school, but obviously the answer that no. Yeah, if you change the way all that potential you have or something like that. You have a lot off. Just stop everything. You have all the steps in the world. You just choose not to use. So it's not about building. Let's go. When you guys go back to 65, you are a page off because you were 4 cents. Double the plus. This point again, you can't balance yourself with questions. I truly do not want to know. I would like to ride off this sunset on the same day and go to that. As long as you balance that, I'm good. All right, so we done with play. All right, so we said that we had a +1 -2 +2 -1 NaCl plus ZnS. We got a +1 -1 +2 -2, cancel them all out. Then we said we needed state. What state did we acquire for NaCl? Aqueous, and for ZnS. Fabulous. Everybody good with that? Yes? Anybody not good? Can we do the work step? All right, do the work step. Were we not breaking apart? The solid, very good. All right, so I'm not messing with ZnF. That one I'm leaving alone. Break the rest of them apart. Okay, over. One. One. Everybody. That's all I got. Now, down to 25 seconds. Yeah, I had to say that. I would definitely say that. I would say, look. Another challenge. I've got to say that. I like it. All right, so work step. What do you have for this one? And we made them aqueous, right? All right, plus the N and plus, and then here. All right, so what are we going to do to figure out the last two steps? Have you already done them?
Yeah.
Okay, so who are my spectators? All right, so spectators are Na plus 1 aqueous, Cl minus 1 aqueous. Make sure you put states and the oxidation numbers. If you only write NaCl, minus 1, minus 1, minus 1, minus 1. You got to write all that stuff down. All right, so for the net, what's left? Does it need to be balanced?
No.
Okay, no, it's already balanced. Everybody okay with that? You think you can do one on your own from start to finish? All right, let's try one. Oh, go back. Okay. All right, last one. You can. Put that into the compound. So what do you think you'll do? Very good. Yeah. I'm not sure. Mark it down. I'm not sure. How old? Well, I don't know. Oh, yeah, you're talking about when you go, I'm not sure. I'm not sure. Wait, I'm probably 1.5. Actually. Oh, wow. No. Ew. Oh, alright. So, can you put the answers up? Here we go. You looking up there while I had homework? Yeah. right, well, Brandon hands out homework.
Right?
What you talking about, Brandon?
Oh, but bro.
Yeah, no. One there, Mike. All right, so, did we come up with Na, C2H3O2, and PbCl2? That's what to be out. Did we get aqueous and salt? Yes, no? Okay. So, from that on, Pb plus 2 plus Cl minus 1. Both of these are aqueous. And you get PbCl2 as a solid. Now, this one has to be balanced because you got 1 chlorine, 2 chlorines, so I need a 2 there. The spectators are Na and acetate. These spectators. Question. No, I'm going to tell you.